All right, so symmetry and odd or even functions. First of all, we have two pictures here. The first one on the left is a graph of x squared, and the one on the right is the table of that graph from the x values -3 to +3. Don't let them scare you, whatever. They're just pictures. Now, how can I tell if a function is even or odd solely on the graph? Solely on the graph. By the way, you guys know that f of x is also the same as what?
Y.
Y. Perfect. Bam. Now, how can I tell if a function is even or odd just by looking at the graph? That has to do with symmetry. What is symmetry?
The line of symmetry is the line that goes through the vertex.
Yes and no. Symmetry, if something is symmetrical, what is something symmetrical? It's the same on both sides, right? So this graph is the same on both sides when we use what is like the mirror, the symmetrical line. The y-axis, perfect. The y-axis is the vertical axis, right here. And this graph is the same on the right side as it is on the left side. It is a reflection of itself. It's symmetrical. And when a function is symmetrical about the y-axis, they are considered even functions. Even functions. See pens, scribbling. All right? They are even functions. I think it's pretty easy to tell when something is a mirror image of itself when it's reflected over the y-axis. All right? It should have the same thing in quadrant 1 as it does in quadrant, what is that? 2. Quadrant 2. Remember, let's counterclockwise. Okay? So what about the table? There's actually an algebraic way to tell if functions are even functions. Okay? There's an algebraic way. Remember, y is the same thing as f of x, correct? And this is your x. What do you notice about the x values in relation to the y values? Look at the x values here and what they output. Well, they are squared, right? The square of 1 is 1. The square of 2 is 4. The square of 3 is 9. But what happens when I negate my x? What happens to the output? So when I look at the output for my positive numbers and look at the output for the negative numbers, what do you notice?
They're the same.
They're the same. So basically, it doesn't matter if x is positive or if it's negative, it should give you the same value. And that's how we can tell algebraically if it's an even function. Okay? If I put a negative x into my function, I should get the same y value or the same output. All right, so let's take a look at this and try and prove algebraically that x squared is an even function. Now, I don't have the graph or nothing. They just give me that equation. This is what they give me. F of x equals y squared. I need to prove that it's an even function. And we now know that if we throw a negative x into the function, that will give us the same output, or it will equal f of x. In this case, f of x is x squared. All right, so I'm going to start. I know I'm going to throw a negative x into the function x squared. All right? Don't freak out, because if I were to do this, if I was to say what is f of 5 for x squared, how do I handle that? Yeah. Wherever there's an x, I just put in a 5, right? So that will give you 25, correct? Same thing here. Who cares if it's a variable? I'm going to put a negative x into x squared. So now I have negative x squared. When I square something, that's like doing what? Multiplying it by itself. So I have negative x times negative x. What is negative x times negative? What's a negative times a negative? Positive. What's x times x?
Positive x. Oh, x.
Yeah, I add exponents, right? It's positive x squared. Is that the same as our original function f of x? Yes, it is. So now I could say, well, negative x does equal f of x. They're both x squared. Therefore, that's what those three dots mean. It's an even function. You know, tell me about it. Tell me about it.
Show me one.
Odd functions. We just covered even. This is odd. All right? So, we have x cubed. And here's a table that goes along with x cubed. Now, we could tell by looking at the graph that x squared was even. But how can we tell by looking at the graph that x cubed is odd? Now, the x-axis. No. If they reflected the x-axis, this is the x-axis here. This would look like that. So it's not the x-axis. Look at the right side versus the left side here. Compare those two. What's it look like it reflects around?
Zero.
The origin. It's on your paper. Yeah. Wait, someone said zero. And zero is at the origin, isn't it? The origin is right here. Right there. Yeah. So, how can something reflect about the origin? Well, whatever point I have, it reflects through the origin. Bam. If I take this point here, it reflects through the origin right here. It does. Take this point in between them, it reflects right between them here. It does. It's almost like rotating at 180 degrees. All right? So it reflects on the origin. And when we see that it reflects on the origin, we know it's odd. Looking at the graph is always the easiest way to tell. It's always the easiest way to tell. But let's say they just give you a table of points and they don't give you a graph. All right? Again, here are my x values. This is my f of x, which is the same thing as my y. Look at the numbers 1, 2, and 3 here and what they output. And then look at the numbers 1, 2, and 3 here and look what they output. They're negative. So that means when I throw a negative value of x in here, when I negate any of these, and I negate them, what happens? It just what? What does my output happen? Look, if I plug in a 3 here, I get 27, right? If I plug in a negative 3 here, what do I get? So I get the negation of the original function. So I don't get f of x, I get the negation of f of x. All right? And that's what's there. That's how you can tell algebraically if it's an odd function. You get the negation of f of x. All right. Let's prove it algebraically. Let's test the scenario in front of us where they don't give us a picture of the graph. You don't have a graphing calculator to check it. And you got to prove that x cubed is an odd function. All right? Again, I'm going to put a negative x into x cubed. What's that? I didn't even stop it, buddy. But thank you. Now that's going to be right in. That's all right. Every once in a while, move backwards like that. All right, so here we go. I'm going to put this in here, and it's going to be the negation of f of x. Well, if f of x is x cubed, when I negate f of x, I should get a negative x cubed. Okay? So when I throw in this negative x, if it's odd, when I throw this in, I should end up with this. All right? Let's do that. I'm just going to throw this into x. Always use parentheses. Always. So I'm multiplying negative x by itself 3 times, not just twice. So what is negative x times negative x? It's x squared, thank you. Times negative x. Is that not the same? It is. So we have f of negative x equals the negation of f of x. Therefore, it's an odd function. I know. All right, so what happens if we have something that's symmetrical about the x-axis? Can that tell us whether something's even or odd? No, because there's only two ways to tell something's even or odd. If it's even, it reflects across the y-axis. If it's odd, it reflects about the origin. If I want to graph this, obviously there is no y squared on this side, so we got to solve for y here. If I take the square root of both sides, that would give me y equals, well, what am I missing? Plus or minus. Don't forget when I square that, if I square a negative, it turns positive, right? But I can't put plus or minus in the calculator, so I have to do it this way. I have to put a positive radical x on one and a negative radical x on the other. Here's positive radical x right here, and here is negative radical x right here. There we go. Now, all right, well, that's, I mean, is it something? If it's not odd or even, how come I can't prove whether it's odd or even? I get an error, not only at -1, what happens under a radical that gives me an error? Yeah, whenever I get a negative number under the radical, I get an error. So if I ever put in a negative x value here, from here on up, they will all give me errors. They will never equal f of x, and it will never equal the negation of f of x, because it will always give you an error. So if they give you a graph that looks like this one here and say, is this even? Don't fall for the trick, because it reflects over the x-axis. It needs to reflect over the y-axis. All right? So they ask you why. Here's why right here. Because when you throw in a negative x into an original function, you will never get it to equal f of x, and you will never get it to equal to the negation of f of x. It'll always give you an error. You can never prove it algebraically. So, a function can be even, a function can be odd, and it can be neither. This is neither. That's fine. It doesn't always have to be odd or even. It can be neither. We're good. All right, this first one. If I throw a negative x in here, I get negative x squared, because I'm throwing a negative x into x. Minus 3, there's no x to throw in there. X squared minus 3. Is that the same as what we started with?
Yeah, so you get an even.
So f of negative x is the same as f of x. It's the same, so therefore, even. Therefore, it's even. All right. A little bit. Now, I'm going to throw a negative x. I start these all the same way, and it's the answer that tells me whether it's odd or even. So you should always know how to start these. Okay? I'm going to throw a negative x into my first x, minus 2 times, I throw a negative x into this one, minus 2. There's no x back there. So, what do I have? This will turn into x squared. Negative times a negative is positive 2x minus 2. This is what I end up with. Is that the same as what we started with?
No.
No, it is not. Is it the negation?
No, because the negative at the end of the
Right. If I were to negate this whole function, I would keep change. It would flip all the signs. The negation of that would be negative x squared plus 2x plus 2. Is that the same? No, it is not. It's not the same as this. So guess what? It is neither. It is neither. Because it does not equal f of x. And it does not equal the negation of f of x. So it's neither. Now this last one is interesting. I've got some people who ended up algebraically correct. They're not sure if it is odd, even, or neither. So we are going to put a negative x in here, and we'll end up with negative x on the numerator cubed, and for the denominator is 4 minus negative x squared. Okay? So what's the numerator going to end up becoming? It'll become negative x cubed over, what is the denominator? 4.
Positive x squared plus x
Wait,
squared.
I am going to negate or subtract a positive x squared, right? Because negative x times negative x is positive x squared, but don't forget I still need to subtract a positive x squared.
So you get nothing.
So it's just like subtracting a positive x squared. Yeah, it's like distributing. What happens when I distribute that? Don't I just get a minus x squared? All right, now, that should be the correct simplification. Now, here's the kicker. Is that's definitely not even because it's not the same. The top is different. It's odd. How come it's odd? This is odd. This is equal to the negation of f of x. Therefore, it's odd. Those of you that forgot, if I have a fraction, let's call it 1/2. What is the negation of that fraction?
Negative 1/2.
Negative 1/2. I could also write that 1 over negative 2. It doesn't matter where the negative is. I can also write that with the negative out front. So as long as the top or the bottom is the negation, that's a complete negation of the fraction. The top is negated, not the bottom. If I negated both, wouldn't that just be negative divided by negative? It would still be positive, wouldn't it?
Yes, I mean.
So as long as I negate just one of them, the whole thing is negative. That's why that's odd. Remember your rules for fractions.